Hi there, guys. This is just Mr. Wee. I just kind of want to help you guys out with the lab. So I feel that I might give you some answers, but the thing is, if you guys are patient enough to listen and learn, it's worth it. Okay, so that's why I think it's okay to kind of go through some of the answers with you guys. I'm going to go through number 3. Most of you guys already started here. We kind of talked about these two in class. I'll go over them a little bit later. Let's talk about number 3. Which direction, forward or reverse, did the reaction shift when the pipette was placed in a hot water bath? Explain using Le Chatelier's principle. Okay, so essentially, okay, I don't know if you can see that. I'm gonna go back to the reaction, what kind of happened here, right? So here's kind of what happened generally, right? We took one guy and we put him in a hot water bath. That's what color it turned. It turned blue. And then I also put another guy in an ice water bath. Look what happened to him. He turned pink. Okay, so that was the reaction. All right, so we're gonna see what happened when we kind of gave it heat. So basically, this is what's in the test tube. We have essentially two sides, okay? O is the left side when we write out the whole chemical formula. It's going to be the reactants, okay? And what I mean by left side, I mean is in between the arrow here, the equilibrium arrow, going back one way and going forward the other way. On the left side of that, we start with reactants, whatever we start with here. And then on the right side is always what we get at the end, the product, okay? So here's what's happening. In that test tube, we actually have a bunch of chemicals kind of floating around. What's happening is this guy is kind of getting used up and reacting and pushing forward to make a bunch of these guys. But at the same time, we have a bunch of products here that are reacting in the reverse way. They're going back to the reactants, okay? So it's going back and forth right now. All right, but sometimes, and that's what we call equilibrium, when both kind of reactions are kind of happening at the same time, all around. We got like a bunch of different particles. Okay, we have a bunch of these guys, the Cls and the Co guys, kind of going towards together, colliding and making these guys, and then we have a bunch of these guys breaking apart and going to this guy. Okay, so this is all happening at the same time. All right, now the thing is, which direction will the reaction shift? Will it go to the left or will it go to the right when the pipette was placed in a hot water bath? So think about hot water bath. That's the key right there. You ask yourself, hot water bath, what does that mean? Am I adding heat or am I subtracting heat from it? Okay, so obviously hot water bath, I'm adding heat into my reaction. Okay, like I said, I have two reactions going on. I have the forward reaction, these guys getting used up to make these guys. And then I also have the other reaction, these guys breaking apart and going backwards into these guys. Look where the heat is, though, right now. The heat right now is on the left side, the reactants. Okay? So think about it this way. I added heat to the system, and the heat is always associated with the left side, the reactants, right? So right now, remember if I go to my computer right now, if you guys remember, let's see if this kind of works. Remember this right here? Her hand right now represents the reactants. They also represent the products. They're at equilibrium right now. But if I add heat, which was on the left side right here, it's on the left side, which is her left hand, okay? And the question is asking, what if I add heat? What if I put the tube into the hot water? Okay, what's going to happen, let's see if I have it here. Okay, what's going to happen is it's going to be like this woman's hands right here. You're going to have more reactant. You have more heat being built up, right? More heat being built up because it's on the left-hand side. That means her left-hand side where the heat already is, you're adding more heat. So she has a lot more reactants right now, like a lot more heat in her reactants. So what she's going to do is she's going to kind of swing her arm over like this way. It's going to swing over down here. So that means that she's going to take her hand and she's going to swing it to which direction? The right hand direction, which is otherwise known as the forward direction. Okay, so what I mean is this. I'm going to have a lot of heat here because I put my reaction, this whole reaction in a test tube, in a hot water bath in a test tube. What's going to happen is I'm adding heat, and all the heat's already in here. So that means more heat is being transferred into the left-hand side. Bunch of heat's going here. That means I have way too much going on here. I have way too much heat here. Like this girl shows, she has way too much heat. That means she has to use that up. And the only way I can use it up is if I go to the right. That means I will make product, okay? So to answer your question here, which direction will it go? It's going to go forward, which is to the right, okay? O is going from left to right. I'm going to the right. That means the right arrow. If I go to the right to use up the excess heat that I'm given, I need to go forward. Okay, so using Le Chatelier's principle, essentially what that means is that Le Chatelier always said, if you stress the system in any way, you change the temperature. So if you, don't write this verbatim, okay? Don't write all this, okay? I'm just giving you a general outline what to write. If you change the temperature, meaning heat is added, then we must use up the heat. Okay, we have to use up the heat, and the heat's on the left hand side. So I say heat is on the left, or reactant side. So that means I have to go to the right. I go forward. So I don't have that much room. So we must go forward to use up the heat. Okay, again, because the heat's associated with the reactant side, I have so much of it that I have to go to the right to use it up. When I go to the right, that means all these guys are being used up to make these products, okay? So if you still have any questions, let me know. That is how you can answer number 3. And also, please just try to understand, okay, the concept, right? Especially for the test or just in general, just to learn, okay? All right, you guys have a good night. Bye.